This video is about complex numbers. Complex numbers are used a lot in quantum mechanics. One example is in the Schrödinger equation, something that you become very familiar with over the course of your undergraduate degree in chemistry. Sometimes the solution to an algebraic equation does not yield a real number. For example, solving x squared plus 1 equals 0 gives the solution of x equals plus or minus the square root of minus 1. This, however, is undefined. But if we define the imaginary number I as the square root of minus 1, then the solution to the equation is now that x is equal to plus or minus I. In general, an imaginary number can be defined as any real number multiplied by I. So the square root of minus 8 can be written as the square root of 8 multiplied by I. Here you can see the general form of the complex number z, where x is the real part and Ri the imaginary part. However, both x and y are real numbers. You can see here that if x is equal to 0 and y not, then z will be an imaginary number, for example 2i. And if y is equal to 0 and not x, instead, then z will be a real number. Now find the real imaginary parts by yourselves for the complex numbers shown below. Pause the video and have a go by yourself. Hopefully you got the answers shown in the table. If not, read through the above again and try to understand why. In order to add complex numbers, you simply just add up the real and the imaginary parts separately. Now try these two examples. Pause the video and have a go by yourself. Hopefully that you got these answers that are being shown below. When you subtract complex numbers, you again deal with the real and the imaginary parts separately. I hope now that you feel a little more confident with complex numbers.